Alright, this is our next lesson here on finding composite functions with inverse trig functions. Composite means more than one or two. So when we're doing a composite function, it means we're really doing two functions at one time. Or we'll be doing an inverse sine function, or sorry, an inverse trig function with the original trig function. So first definition here. If I want to call it composition or composing for composite function, I want to compose the inverse function with the original function. So inverse of f composed with f of x, or we're going to say the inverse of f at f of x equals, now this is the first definition is going to be for sine. So sine inverse of sine of x. Okay? So we always work from inside out. So first we would take the sine of x, and then whatever we get there, we'll get a ratio value, and it'll be the inverse sine of that ratio value against the angle. So usually in mathematics, inverses cancel out with their original operation, like multiplication cancels out division, addition cancels out subtraction. Well, the inverse sine will cancel out the sine, and this will equal x, but only if our domain is the right values, right? For sine inverse, it must be between negative pi over 2 and pi over 2. Okay? We can go the other way. We can do this way. F of the inverse at x equal to the sine of the inverse sine of x. Okay? Instead of taking the inverse or the sine and then the inverse, take the inverse and then the sine. Go both ways. Now, these will also cancel out, and you'll just get x, but only if our domain for the inverse is the right value, or the domain for the inverse function must be between negative 1 to 1. Okay, that's the definition we're going to start with. All right, our first two examples, we want to find, see the inverse sine of the sine of pi over 8. Now you might think, oh, okay, these are going to cancel out, inverse sine and sine. Well, you got to check and make sure the domain for sine is within the right values. So you got to check, is pi over 8, or 1/8 pi, might be easier for you to say, is 1/8 of pi greater than or equal to negative 1/2 pi? Yes. Is it less than or equal to 1/2 pi? Yes, 1/8 is less than 1/2. Yeah, we're good. I put a little check mark. It's okay, which means that these will cancel out, and you'll get pi over 8. Right? We took the sine of pi over 8, which will give us the ratio value, and then we take the inverse of that ratio value, will get us back to the angle. Number 2, a little bit trickier. Again, so you gotta check and make sure 5 pi over 8 is within the correct angle for sine that it uses. Well, it has to be 5/8 pi. Must be greater than or equal to negative 1/2 pi, which it is, but it is not less than 1/2 pi. Right, 1/2 pi is 4/8, 5/8 is not less than that, so no good. But we can find another angle, so we get our unit circle here. Sine, we must use angles only from negative pi over 2 to pi over 2. So we can only use quadrants 1 and 4. 1 and 4. 5/8 pi. Here's 1 pi. That would be 4/8, which means 5/8 pi is right here. Oh, sorry. That would be 9/8. Here's 4/8 pi. This is half pi, 4/8. So 5/8 pi is right there. We need to find an equivalent angle that's in quadrant 1 or quadrant 2. The sine is positive here, so we need to use the quadrant where sine is positive. Sine is also positive in quadrant 1. We need to find an equivalent spot in quadrant 1 to 5/8 pi. We'll see that's 1/8. This is 4/8. This is 5/8. This is 1/8 away from the y-axis. So I'm going to go 1/8 away on this side. That'll be 3/8 pi. So I can rewrite this as, let's go arrow, inverse sine of the sine of 3 pi over 8. Now, since this angle is within the right domain, these cancel and I get 3 pi over 8. All right, we're going to do a couple more for sine. This time, notice we're going the other direction. Add the sine of the inverse sine of 0.8. Okay, we're going in the other order now, taking the inverse sine first and then the sine. So you got to check and make sure this is in the domain for the inverse. This value, this ratio value, has to be between -1 and 1. As you can see, 0.8 is between -1 and 1, so we're good. Check mark, okay, it's worked. These cancel out, we're left with 0.8 or 0.8. Next one. Take the sine of the inverse sine of 1.8. And check. -1 is less than or equal to 1.8, yes, but 1.8 is bigger than 1. It's not in the domain. Now, for example we did before, we could find another angle that worked. However, this is not okay. This is saying, what angle is the sine 1.8? When is sine equal to 1.8? And you say, never. Sine goes up to 1, down to -1, up to 1, down to -1. It's never going to be at 1.8, so not in domain or undefined. And that's it. Okay, for our next one, notice up here had that similar definition that we had for sine, but now this is for cosine. Only difference is remember the angles that cosine can use when we're doing inverses is not -2 to power 2, but 0 to pi. So once you go ahead and pause the video and write that first, and then we'll do these examples. Okay, so number 5, inverse cosine of 1/12 pi. So you gotta check this angle. Okay, cosine uses angle values. Is this between 0 and pi? And you can just see right now, yeah, 1/12 is bigger than 0 and less than 1 pi. So we're okay. Inverse cosine cancels with the cosine, and you're left with 1/12 pi. Okay. Number 7, this angle, -2/3 pi. Well, you gotta check. Is it between 0 and pi? See, -2/3, no, it's not greater than 0. Not okay. Not okay. So we need to find an equivalent angle somewhere else in the circle that will work between 0 and pi. So draw our unit circle here. Here's 0 radians, there's pi radians. Let's find -2/3 pi. That would be, that's -1/3 pi. -2/3 is right about here. That's -2/3 pi. Okay, we need to find an equivalent spot on the unit circle that's within the angles we can use, 0 and pi. We need to find an equivalent spot in quadrant 1 or quadrant 2. That's what inverse cosine uses, or cosine uses. Well, cosine is negative in quadrant 3. So I need to use the quadrant here that will make cosine negative. Cosine is negative in quadrant 2. So I need to find an equivalent spot in quadrant 2. A couple ways to think of this. See. -2/3. Well, this is 1/3 pi away from the y-axis, or 2/3 away from the x-axis. So I need to be 2/3 from the x-axis, or 1/3 from the y-axis in quadrant 2. So that would be somewhere up here. And we count forward from 0, so that's 1/3 pi, 2/3 pi. That's the angle we want to use. Okay. Another way you can do this is see that, remember from a couple of units ago, cosine is an even function. So cosine of -theta is equal to cosine theta. So I could have just rewritten this as cosine of +2/3 pi. Right, those are equivalent. And okay, 2/3 pi, that's within the right domain. Inverse cosine cancels with cosine. 2/3 pi is our answer. Okay, last 2 problems. Now for tangent. So top here says you pause this and write down these definitions for tangent. Similar to sine and cosine, or the inverse of tangent of the tangent and the tangent of the inverse tangent. They cancel only if the angle is in the right domain or the ratio value is in the right domain. Now, tangents like sine uses -1/2 pi to 1/2 pi. And then the inverse tangent is -infinity to infinity, because the original tangent graph, right, the range is -infinity to infinity. Right. So, here, tangent of 4/5 pi. We need to check is 4/5 within our ratio, our range, or sorry, domain there. Well, negative 1/2 pi to x to 1/2 pi. Oops, x is 4/5 pi. Well, 4/5 is bigger than 1/2, so no, this is not in the right domain. We need to find an equivalent angle. Circle here. Find 4/5 pi. Here's 1 pi, so 4/5 is 1/5 less than pi. 4/5 pi is right there. Okay. Tangent uses negative 1/2 to positive 1/2. Negative 1/2 to 1/2 pi. So we need to find an equivalent spot in quadrants 1 or 2. Let's see. Tangent is negative in quadrant 2. This angle will give us a negative value for tangent. So we need to do this quadrant, sorry, not 1 or 2, quadrants 1 or 4, which will give us a negative value. Tangent is negative in quadrant 4. So we need to find an angle in quadrant 4. This is 1/5 from the x-axis, so I'm going to go 1/5 from the x-axis over here. Remember, this is from negative 1/2 to positive 1/2, so I'm going backwards, or negative 1/5 pi. So our equivalent angle is negative 1/5 pi, or negative pi over 5. So actually we should change this to negative pi over 5. Now, since it's in the right domain, these cancel and you get negative pi over 5, or 1/5 pi. Okay. Number 9 here. Other direction, take an inverse first and then the tangent. Well, you need to check, is this value in the domain for the inverse tangent? Well, the inverse tangent goes from negative infinity to infinity. So yeah, negative 2 is within negative infinity to infinity. This value is okay. Tangent cancels out with inverse tangent.